Example number 2. Evaluate integral x power 2 plus 4x plus 1 divided by x minus 1, x plus 1, x plus 3 times dx using partial fraction method. So here first we need to check whether the given problem is a proper function or improper function. It is easily identified that the degree of the numerator of p of x is less than the degree of the denominator g of x. So I can say this is a proper fraction. And if you see the denominator, I have three different or distinct linear factors in the form x minus 1, x plus 1 and x plus 3. So using partial fraction rule, I have to introduce three values a, b and c. So a over the first linear factor plus b over the second linear factor plus c over the third linear factor. This one I have to name it as equation number 1. The next step, I need to multiply both sides of equation number 1 by x minus 1, x plus 1, x plus 3. So if I simplify this, I will get this one. X power 2 plus 4x plus 1 is equal to a times x plus 1 times x plus 3 plus b times x minus 1 times x plus 3 plus c times x minus 1 and x plus 1. Now I need to find the value of a, b and c. For this, I am going to substitute x equal to minus 1 in this equation. Let us say this is equation number 2. So we have to substitute x equal to minus 1 in equation number 2. Then I have to substitute x equal to 1 in equation number 2. Then I have to substitute x equal to minus 3 in equation number 2. So that will give you b value as 1 by 2, a value as 3 by 4, c value as minus 1 by 4. Then we have to substitute a value, b value, c value in equation number 1. In the last step, we have to integrate every term by x. So first term integration with respect to x, second term integration with respect to x, third term integration with respect to x. Before integration, take the constant outside. So from this, take 3 by 4 outside. From this, take 1 by 2 outside. From the last term, take minus 1 by 4 outside. Then for the remaining term, if I apply integration, this will become ln x minus 1. Second one, ln x plus 1. Third term, we have 1 over x plus 3. So integration of this will be ln x plus 3. Let us move on to question number 3. Evaluate 3x plus 2 divided by x minus 1 times x plus 2 the whole square. So as usual, in step number 1, we will check and we come to know it is a proper fraction. But this time, if you see the denominator, we have a combination of linear and repeated factors. So for the first linear factor, x minus 1, I introduce the value a. For the repeated factors, x plus 1 the whole squared, I will write b and c. Then as usual, we have to keep this is our equation number 1. In the next step, multiply equation number 1 both side by the value x minus 1 times x plus 1 the whole square. If you cancel the common factors, we have left with this equation. So take it, this is equation number 2. So from equation number 2, I can get the value of a, b and c. So first I will substitute x equal to minus 1 in equation number 2. I will get c equal to 1 by 2. Then I will substitute x equal to 1 in equation number 2. I will get a equal to 5 over 4. To find the value of b, there is no values to be substituted in equation number 2. So what I do, I am going to equate the coefficient of x to the power 2 on both sides of the equation number 2. If you see equation number 2, in the left hand side, there will be no x power 2 terms. So it will be 0. Then compare the right hand side, you have two values. One is ax power 2, the other one is bx power 2. So I have like this, ax power 2 plus bx power 2. We have already know that the value of a. Okay, so what I'm going to do, I'm going to compare the coefficient of x power 2. I already inform you there is no x power 2 terms in left hand side, so we have 0. If you see the right hand side, there will be a and b, so we have a plus b. I have already know that a equal to 5 by 4. So substitute the value of a equal to 5 by 4 here. We will get b equal to minus 5 by 4. Then what is my next step? I need to substitute a value, b value, c value in equation number 1. Then I have to integrate all the three terms. So before integration, take 5 by 4 outside, take this 5 by 4 outside, take this 1 by 2 outside. For the remaining term, if I integrate, I will get this as my final answer. So these are the exercise problems, and in the right side I have given answers also. So using the previous methods and ideas, I request you to kindly do these problems. See you in the next video.